Hi ladies and gentlemen, this is Mr. Green again. This is another in my series of AP Statistics videos. You should be working in Unit 5 right at the moment, and just a reminder, we're getting near the end of the semester. Now's not the time to let things fall behind on your due dates. You want to make certain you get everything accomplished and completed, because that's the way you're going to get your grade, is when you get things completed. Okay? We're going to be talking about discrete random variables today. Okay, so that's one of the topics in the AP statistics outline. So, what is a random variable? Random variable is a numerical variable whose value depends upon the outcome of a chance experiment. Okay, let's use the example of rolling a dice. If you roll a dice, that's a chance. You have a 1 in 6 chance of getting an outcome, and the outcome you're going to get is numerical in nature. It's a number that you're getting. That is what we're talking about with a random variable. It's a numerical variable, a numerical value that you have a possibility of getting different numbers on. Okay? So there's two types of them. One of them is the discrete random variable, and the other one is a continuous random variable. The discrete one is the easy one to describe. That is the rolling of a dice. Okay, you're going to get one of 6 different numbers: 1, 2, 3, 4, 5, or 6. Or if you're rolling 2 dice, you're going to get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You've got very discrete numbers that you're going to get. Okay, a continuous one is where you've got a continuous it could be anything between these ranges, or it's any real number that it could be out there. So a continuous one is a little bit more difficult to describe, but we'll get to it here in just a minute. So if we're looking at discrete probability distribution, gives you the possibilities. It gives the probabilities associated with each possible value of x that you could have. Okay? It's usually displayed in a table, but it can be displayed in a histogram or in a formula. Okay? So for every possible x that we get out there, the probability for all the values has to be between 0 and 1. I mean, you can't have something more than 1 as your probability of an outcome, or else it wouldn't be a probability, would it? Okay? But for all the values of x, if you add up all the probabilities, they're going to be equal to 1. Go back to that single dice that I talked about. If you roll a single dice, the probability of getting any one value on that dice is 1 out of 6, right? Well, that's what this is saying here. 1 out of 6 is less than 1, it's greater than 0. My probability of rolling any one of them is a 1 out of 6. If I add up all the probabilities, 1 out of 6, add it up 6 times, is going to give me 1. Okay? So the total sum is going to be 1. Now, suppose you toss 3 coins and record the number of heads that you got. That's a random variable defined as the number of heads tossed up. Okay, the number of times you got a head when you tossed the coin. So if we wanted to create a probability distribution about that, you could either get 0 heads, you could get 1, you could get 2, or you could get 3. And if you go back and look at the video I drew last time, where I drew that probability tree, okay, you could actually see that the probability of getting 1 head, well, there were a couple of possibilities of that on that tree, and if I added the 0.125 3 different times, I would get this 375. And there were 3 probabilities of getting 2 heads. So if I add those together, I would get 3.75. If you add across here, you're going to get 1. I mean, 1.25 plus 3.75 plus 3.75 plus 1.25 is 1. And that's what you're going to get. So they're asking me to create a probability histogram. Well, this is real simple. I could just key those values into L1, and I could get this probability histogram and create it out here. This would be 1.25, this would be 1.25, and this would be the 3.75 going across there. Okay? Not that big a deal. Okay, so let's look at, let x be the number of courses for which a randomly selected student at a certain university is registered. They could be registered in 1, 2, 3, 4, 5, 6, or 7 classes. Could they be registered in 0? Well, they wouldn't be a student if they were registered in 0, would they? Okay? So, this is the probability table down here. They're telling you 0.2, 0.3, 0.9. Oh, they didn't give me a probability for 4. One way we could find this probability would be to add these all up and subtract it from 1, because it has to add up to 1, right? So if I subtract it from 1, what do I get? 0.25. So that means this probability of 4 is 0.25. What's the probability of them being enrolled in less than 4 courses? Would be the sum of 1, 2, and 3. So I can see that be 1.14. Okay? What would the probability of being less than or equal to 4? Well, that's where I got to add this 0.25 onto that number, and I would get this 0.39. What's the probability that the student is registered for at least 5 courses? What does at least mean? At least means less than or equal to. So I'd be looking at less than or equal to 5. So that would be 0.79. Because I would add the 0.4 onto the 0.39, I'd get 0.79. I hope you guys see how I'm getting those values in there. If you don't, please feel free. Come by Toga and ask questions about it. Okay? Oh, at least 5. I'm sorry. That's going to be 5 and greater. So I'm going to add up this 0.4, this 0.16, and this 0.5, and I'm going to get 5.6, 6.1. So that's where this 0.61 comes from. 61% of them have 5 or greater number of courses. Okay? So, continuous random variables are numerical variables whose values fall within a range or an interval of ranges. All measurements can be described by density curves. So what we can do is you can be looking at a density curve here. A density curve is always on or above the horizontal axis. It has an area exactly equal to 1 underneath it. It often describes an overall distribution and describe what proportions of the observations fall within each of these range of values. Where have we seen this before? Our normal distribution curve, right? That normal distribution curve, we have that table that tells us what area falls in under for different values under that normal distribution curve. You can go back to that table. That table will help us in this situation. Okay, what are some unusual density curves? They can be of any shape. They're generally generic continuous distributions. The probabilities are calculated by finding the area underneath the curve. Okay, so it's not like it's hard to do. One of them is called a uniform distribution. This is a continuous distribution that is evenly or uniformly distributed. It has a density curve in the shape of a rectangle. It just looks like a big old rectangle out there. The probabilities are calculated by finding the area under the curve. So we could actually find the area of the rectangle, right? Okay, so if my mu at a certain x is going to be equal to a plus b over 2, where a and b are the endpoints of the uniform distribution, and my standard or my range here, I'm sorry, this is standard deviation squared, so this is my variance here, is going to be equal to b minus a, the high point minus the low point, squared divided by 12. This is just how it works out to be the standard deviation. Okay? Those are formulas that you can use if it's a uniform distribution. Look for that word and I think it'll help you. How do you find the area of a rectangle? You multiply the height times the length, right? So we can actually find a particular probability. Oh, didn't show it to me there. I could find the different probability by actually adding or finding where this value is. Take the minimum value minus the value that I'm looking for, right? And that would tell me the length of that side, and then whatever the value or the distribution value is, and multiply it out. It's really not a difficult process to find the area of a rectangle there. Okay? So here's an example. Here I've got a rectangle down here in a uniform distribution. It goes from 0.492 or 0.492 to 0.504. Okay? But they're asking, what is the probability of selecting a bag that will weigh 4.97 pounds? Well, here's 4.97. That's what this line here is representing. Okay? So if I took 4.97 minus 4.92, that's going to give me, oh, I'm sorry, more than this. So I'm taking 4.97, 5.04 minus 4.97, and that's going to give me what? 7 tenths, 0.07, 7 100ths. And I'm going to take that 7 100ths times the 1 divided by 0.12. And that's going to tell me the area in this purple area here. You can see where that's coming from. The 0.7 is from here to here. That's the difference between those values. And then the 1 over 112, 1 over 0.12 is this height right here. That was the uniform distribution that we had going across here. And so I can take those two, do that division, and wind up with the probability that a randomly select bag will weigh more than 4.97 pounds in this situation. That's 58% of the time. Cool? Okay. Well, that's the way these random variables are used in this situation. Okay? If you have any questions about it, feel free to come by Toga and let's talk about it. I do appreciate the fact that you guys have been very good about sending me your course number and that you're in AP Statistics. It helps me answer your questions that you have so much quicker. And I will look forward to seeing you in Class Connect this week. Talk to you later. Bye.